Hey there, legends of the keyboard. Welcome back to the channel where code turns into creativity. And today, we're diving into a super cool project, a binary clock in C# using WinForms. Yep, you heard right, we're throwing numbers out the window and going full binary mode. By the end of this video, you'll have a fully working binary clock with glowing LED style panels, real-time updates, and a slick UI, all done step by step. And if you're new here, don't forget to hit that subscribe button, because you're going to want more of this brain-tingling content. Alright, let's light this thing up. Let's get started with a brand new Windows Forms app in C#. Open up Visual Studio, create a new project, name it my_binary_clock, and hit create. Inside your form, go ahead and double-click on the form to generate the form1_load event. This will be our launch pad, the binary basecamp if you will. Alright, before we start building this awesome binary clock, let's talk about these VIP variables we declared at the top of our form. This is our heartbeat. We'll use this timer to tick every second, literally. Every tick will trigger an event to update the LEDs on the clock. Without it, our binary clock would just sit there like a digital fossil. Now this one's super important. It's a 2D array of panel controls. Think of it like a grid, 6 rows by 6 columns. Each panel represents one bit of one-time unit. So when a bit is on, we'll light it up, like cyan, and when it's off, it'll stay dark, gray. Basically, this is the LED matrix of our binary display. This is where the binary magic lives. Each of these numbers is a power of 2. We'll use these values to check which bits are active in each time unit using bitwise operations. So for example, if the current minute is 18, its binary is 010010, and panels for 16 and 2 will light up. And finally, our friendly row labels. Each of these strings represents a different unit of time. We'll use them to label each row in our UI so viewers and users know what the blinking lights even mean. So yeah, these variables are our backstage crew, quietly setting the stage for the binary light show that's about to begin. You don't see them in the spotlight, but trust me, without them, this clock wouldn't tick. Now that we've declared our variables, it's time to bring our form to life. This sets the title of your window. You know, that thing at the top of the app that proudly announces, "Hey, I'm a binary clock and I know it." You can name it anything, but my binary clock just sounds cozy. Here we're sizing our form window. We want enough space to fit all 6 rows and 6 columns of our LED matrix plus the labels. 450 by 400 gives us a nice, roomy layout without feeling too cramped or too zoomed out. Pro tip, you can always tweak this later depending on how chunky your panels are. Ah yes, our LED grid, finally getting some structure. We're creating a 6 by 6 array of panels, just like we planned. Each one will represent one bit of one-time unit. That's 36 panels. 36 tiny boxes ready to glow on command. Glorious. Okay. This is where the real magic happens. This method builds and lays out the actual UI, the labels, the panels, the color scheme, everything. Think of it like building the stage before the band walks in. You'll see how that method works in just a second. Spoiler, it's clean and satisfying. We're setting up a timer with a 1-second interval. That means every 1000 milliseconds, it's gonna raise its hand like, "Hey, update the clock." And we're off. This line kicks things into motion. Without this, your clock wouldn't move. It would just sit there, mocking you. But with this line, it's alive. So with just these few lines, we've set up the form, built the LED matrix, initialized the UI, wired up a timer, and launched our binary clock into the world. Not bad for 5 lines of code, right? Stick around. Next we dive into how to actually build the UI and light up those LEDs like a New Year's countdown. This is where we do all the layout magic, placing the labels, panels, and setting the background. Let's walk through it step by step like we're setting up a sci-fi control panel from scratch. Here, we're looping over all 6 columns, and for each one, we're creating a label that shows the bit value. You remember those powers of 2? 32, 16, 8, 4, 2, 1? These labels sit at the top of each column, letting the user know which bit they're looking at. It's kind of like putting the gear ratios on a manual transmission, nerdy, but extremely helpful. Also, notice how we use location equals new point 90 plus call 50, 5, that's spacing them out horizontally with a nice 50 pixel gap between each. Next, we go row by row, adding a label for each time unit. Second, minute, hour, day, month, year, just like you saw in that labels array earlier. Each label is aligned to the left of the corresponding row of panels, so when our binary lights start blinking, we know what we're looking at. Here comes the fun part, we nest another loop inside the row loop, and this one creates the LED panels. Every single cell in the 6x6 matrix is a panel, just a simple box that starts off gray, that's off. And later turns cyan when it's on. We give each panel a size of 40 by 40 pixels, and space them out evenly so the grid looks clean and organized, like a digital spreadsheet with style. We store each panel in our LEDs array so we can access and update them easily later when we convert the time into binary. And to really make the cyan bits pop, we give the whole form a black background. Because let's face it, glowing lights on a dark background just scream cool futuristic interface. So to sum it all up, this method builds the entire visual grid of our binary clock. We've got bit value labels across the top, time unit labels down the side, a matrix of panels ready to blink and shine, a sleek, dark theme that makes your clock look like it belongs on a spaceship. Stay tuned, because up next we'll dive into the brain of the clock, the update watch method, where we finally convert time into binary and make those LEDs blink with purpose. This next method, update watch, is the heartbeat of our app. It runs every second and makes sure those beautiful binary LEDs blink exactly when they're supposed to. Here we grab the current time, sliced and diced into 6 units. Seconds. Minutes. Hours. Day. Month. And the last 2 digits of the year, that's what year %100 gives us. We store them all in an array called time units, so we can loop through them in order, from fast-ticking seconds to slow-moving years. Each of these will be displayed in binary, row by row. We loop through each row. Remember, each row represents one time unit. So row 0 is seconds, row 1 is minutes, and so on. We grab the actual number for that unit, say, it's 42 seconds, and store it in value. Here comes the coolest part, this is where we do real-time binary decoding. We loop through all 6 columns, and for each column we check if that bit should be on or off. We use a bit mask with this little piece of wizardry. This means, if this particular bit is set in the number, light it up cyan. Otherwise, keep it gray. So for example, if our seconds are 42, in binary, 100 1010, the LEDs on columns 0, 2, and 4 will light up. The rest? They stay chill in gray. Boom. Instant binary. So every second, update watch takes a fresh snapshot of the time. Converts each part to binary, and updates our glowing LED matrix like a retro-futuristic time display, hourglass emoji, floppy disk emoji. It's efficient. It's satisfying. And let's be honest, it looks really cool. Now that everything's connected, from the layout to the logic, your binary clock is ready to tick away like it belongs in Tony Stark's basement. So in principle we are ready, but a small error has slipped in which would currently lead to an error in the program. Please try to start the program yourself and fix the error. Write me in the comments if you have found it. I will now show you the solution and then start the clock. Oh. That's only 5 labels, but your binary clock is still working with 6 rows of data. In your update watch method, you're updating 6 rows, 1 for each time value. But if your labels array only has 5 entries, when we try to draw the UI using text equals labels row, it'll go fine for row equals 0 to row equals 4. But once it hits row equals 5, boom. Index out of bounds. That's right. C# will throw an error because you're asking for a label that doesn't exist. Your app crashes. Your clock explodes. Okay, not really, but your app definitely won't run. Each time unit, second, minute, hour, day, month, year, must have a matching label to be displayed correctly. Think of it like putting the wrong caption under a photo. Your users will get confused, or worse, you'll get a runtime error and your beautiful binary build will go bust. Just double check that your labels array has exactly 6 values, in the same order you use in your update watch method. It's a simple fix, but an important one. Clean code. Happy clock. So the clock works. However, we still have to adjust the labels a little as they overlap a little with the LEDs. We can easily do this in the code. See for yourself. Then we start one last attempt. So here we go. Let's recap what we did like the binary bosses we are. Created a 6x6 LED matrix. Used bitwise logic to visualize time. Hooked into a real-time timer. Made it look good while doing it. All of that in under 20 minutes? That's what I call code confidence. If you enjoyed this video, if you learned something new, smash that like button. Drop a comment like I love binary time and tell me what project I should tackle next. And hey, if you build your own version, tag me. I'd love to see your binary beast in action. This has been AS SharpDev, signing off. Stay curious, keep coding, and I'll see you in the next one. And don't forget to have fun.